Today we're going to discuss software development methodologies. In the same way that many different programming languages have been developed, we've also developed many different ways of going about building software. And today we're going to have a look at some of the more common varieties of this and the features of those different methodologies. So we can start by asking ourselves a question, or a series of questions in this case. How would we organize the development of, say, for example, hospital's patient record system, where you need to be exceedingly accurate, otherwise people could die? Or a website, which is fairly straightforward, or a shop's point of sale system where you're dealing with banking transactions. A mobile game, which could be quite complicated because it has to run on multiple screen sizes and multiple operating systems. A personal spreadsheet, which keeps track of, say, for example, your working hours or the taking of a daily income at a restaurant or something like that. Or what if we wanted to try out a new form of financial planning software? We're not really sure how it's going to work or how it's going to integrate or how we're going to have the user interface set out. What type of methodologies might we use? Well, we could ask ourselves, what are the differences between these projects? And if we were to think about it, a lot of them are quite different in terms of scale, the amount of money that they might require, the people that would be building it, the skills that those people would have. We could ask ourselves, what is the same? Is anything the same? Well, if we were to stop to think about it, yeah, we probably have to understand what it is that we're trying to build. We probably need to prepare or plan how we're going to build it. We would probably want to test whether it works or whether we've actually solved the problem. So there's probably going to be some similarities as well. In this course, we break this down into a series of considerations that we actually look at when we come to building software. And this is a good list to remember. So if you're coming to answer an exam question where you've got a scenario and it's asking you to recommend or identify and recommend a development methodology, these are the sorts of things that you want to look at. The formality of the development required. Some are very formal. Some scenarios might be fairly laissez-faire. The sort of budget that we have available to us, the time that is available versus required, the expertise that's available, the size of the solution ultimately when it's complete, and the complexity of the finished solution and the quality required. Now, it may surprise you to sort of, what do you mean quality? We would expect it to be perfect, right? Actually, no. A lot of the time, near enough is good enough. So, but not always. So just bear that in mind. Okay. We look at 5 standard approaches in this course, and you need to know these extremely well. Okay, so first of which is the structured approach. This is for high-end development with large budgets, large number of people, and everything else. The Agile Development methodology, which is about bringing applications to market quickly. Prototyping, which is experimenting with new ideas and processes and basically trying to find out what's the best way of solving something ultimately. A rapid application development, which is small in scale, small teams, small budget, and this is one of those cases where near enough is good enough. And finally, end user, which is built by the person who will ultimately be using it. That is the smallest level of development. All right, so let's have a look at the structured approach in a little bit more detail. So the structured approach is highly formalized. It has 5 set stages that we go through. Each stage has its own characteristics. It is identifiable with large budgets, large teams, highly skilled with narrowly focused developers. For example, you don't find people that are multitasking between front end, back end, and all the rest of that. You'll have long lead times, essentially meaning you've got a long time to develop the software. Anything that's kind of complex will be covered by the structured approach, and the quality of the final product will be really important. You will need to break down your development into these 5 things you have to remember, these 5 stages. We define the problem. We plan the solution. We build the solution. We test it. And then we modify the solution based on what we've discovered through testing. So let's look at it in a little bit more detail. Defining the problem. Before any development will take place in a structured development methodology, the requirements must be clearly identified and understood. This will be considered the most important stage of development because it sets the direction for everything that comes after this. If you set out in the wrong direction, the longer you go along, the more expensive it's going to be to fix it. So this is usually the most serious time of the development. You'll basically find that systems analysts and project managers will do most of the work at this stage. They'll look at what it is. Well, how can we say the end product has been successful? How have we solved the problem? How can we say this is a finished solution? As such, it's heavily focused on the needs of the end user. If you get things wrong at this stage, it is very, very serious. Once we've defined the solution, we move on to platinum the solution. This is where we work out what languages we're going to use. We set out the time frame that things are going to be built. We're going to work on the data structures. These are the classes and the objects in the system. It will be broken down into the modules, and solutions for each module may actually be built in pseudocode first using flowcharts or algorithm design to essentially show how the thing might work. The user interface will be designed, mocked up at this stage. So your screen designs and storyboards will be used in this section. When we come to building the solution, all the plans are finished at this point. So essentially the developers are given individual sections to complete. They will then work on those. We will look at how this actually works a little bit more in the Year 12 course. But essentially you're, as a developer, given a section of the code that you're responsible for. These will be a series of classes or a module that you need to work on. You'll be given the data structures, all the parameters that you need to use, all the inputs and outputs that are expected from your modules. Once they're completed, they're put together to form a solution. When we come to testing the solution, there's two types of testing that we'll use. There's alpha and beta testing and acceptance testing. Now, alpha/beta testing is done for anything that goes out to in a commercial sense. So we don't have a client necessarily. We have end users who can purchase the software, so we'll need to do alpha and beta testing. Acceptance testing is done when we're building it for a specific client. This is when they go through and they decide, yep, we accept this solution and we're going to write you a check. Testing is actually done by people who specialize in finding problems in software. It may surprise you to hear that there are people who actually, that's their job, is to break software. They are meticulous. I have met a few. In fact, a good friend of mine is one. They are meticulous. They are devious in the way that they test the software. They will find things that you would just be completely surprised by. And as such, they tend to be somewhat loathed by the developers. Testing will check whether we've met the outcomes. It will test load and performance, and also obviously testing that it's free from any obvious errors. In the modifying stage, the solution, we basically need to make sure that we remove any errors from the program. We add features to a program. If, let's say, for example, modifying might include version 2 of a piece of software or 2.1 of a piece of software. And we update the way that the program performs its functionality. So it's any significant change to the actual software. Maintenance is often completed by different developers from those who actually built the system in the first place. Development teams come and go on a project. So it's quite likely this is actually going to be built or maintained by somebody other than the people who actually built it. And as such, it's very important that we build software in a very structured way for these people, because the more, the better that you've built the software in the first place, the easier it's going to be to maintain. Now, this is the scary part. Maintenance is completed using the same 5 steps as the main development. For example, you'll define what needs to be changed. You'll plan those changes. You'll implement those changes. You'll test that the changes have been made. Then you'll modify the changes based on the testing data that you received. And this goes on and on and on, which is why it's sometimes called the waterfall method. All right, let's look at Agile Development. Now, Agile Development is almost completely different. It couldn't be more opposite to the structured development. It's faster getting a working solution to market. It uses iterative updates to add features and to fix bugs. So essentially, if you see the word iterative or frequent updates in a question, it's almost certainly Agile Development. It's heavily team-focused. Okay, so this is all about the team, to the point where it almost becomes ironic. It often uses pair programming. So you will sit next to somebody and you'll build software together. It's really good at responding well to changing specifications. So if you've ever used an application, say on your mobile phone, and if you sort of think back, 2 years ago, this was a completely different app. They've been using Agile Development, and they've essentially had an idea and they've responded to user feedback, and they've developed the application in quite possibly a very different direction as a result of that. So there's a lot of collaboration between development teams and end users. It's essentially the end users that are driving the development of the piece of software. So some great examples of this, Minecraft, in the early days of this, Mojang used Agile Development, and they essentially, and this was, if you were around for the alpha/beta stages of Minecraft, you would definitely identify this. Whatever weird idea they had at the time, that's what they would focus on, and that's what they'd build, and they'd roll out these, somewhat weird and idiosyncratic updates for Minecraft. Now that it's moved to Microsoft, it's much more structured, and I think perhaps a little bit more boring. Google updates their services frequently, and they use Agile Development. Apple use a lot of Agile Development as well in a lot of their internal applications that they build. Website development tends to be Agile, and large companies will use it for internal projects in a lot of ways. Okay, so let's have a look at prototyping. Now, there are two types of prototyping, and it's heavily focused on the end user experience. Okay, so we use this if we don't really know what it is that we want, or we're not 100% sure how we could solve the problem, and we're willing to throw some money at some prototypes to see which way is actually going to work out best. So it's usually a smaller team with a smaller budget. As I said, there are two types: evolutionary and experimental, or sometimes called fact-finding. The evolutionary prototypes are used to test features, test ideas, with the expectation that they will be rolled into a more formal development methodology. So you'll try out a few things once, something will stick, and then that will be rolled into a more structured development process. Experimental prototypes are developed on the understanding that they're going to be basically abandoned at the end of the testing process. So we're going to use the prototype, gather some information, work out what we're planning to do, then discard everything. There is still a development cycle. So you'll define the problem, you'll plan the prototype, build the prototype, check the prototype, modify the prototype, etc. But again, it's not as formal as the structured development approach. Rapid application development, or sometimes called RAD, was a horrible thing to have in the 2000s. Everybody said, "Oh, it's RAD, sir." Very irritating. Rapid application development is basically an informal method of developing software. You'll largely use pre-existing libraries of code. There's usually, again, a large amount of communication between the client and the customer, but overall it's a short time period, small scale projects, low budget, only really suits some types of projects because ultimately you're probably not going to solve the problem 100%. You're going to get it close enough to be acceptable because you are essentially building it to be quick. End user development, this is the smallest type of development. It uses standard software packages, okay, so anything that's pre-existing. The user is the developer and the maintainer, so as such, it's got no formal stages. It may never be finished. It's whatever money the end user has to spend. So this will be time tracking software that a developer builds, like a small website to track hours on a project. As I used an example before, say a restaurant wants to keep track of its takings at the end of the night, they might build a spreadsheet for that and then basically update it as they need. As time goes on, they realize they could create some reports to see what their monthly takings are, so they develop something along those lines. And then they put in features to test how much money there is outgoing, things like that. So it just basically no formal stages of development. It's just one person building it. And it's very, very low end.